Hello, fellow Java developers. Welcome back to our Making an Example of a Real-World Apache Camel Application series. In this video, we will work with JMS to send our request to Artemis MQ and receive a response. We'll add a route with JMS Endpoint for that. Let's begin. Let's start with overview of what we have and what we need to do. We already have our camel route that reads a file from SFTP server, and we already have a route that sends an HTTPS request and receives a response. The only integration that remains is integration with this client send service over Artemis MQ. We will need to send a client send request XML to the service through some queue and receive an XML response and log the status into the database. So let's go to IntelliJ. Here we have our read document route that reads the initial file from the SFTP server. We also have our sign document route that creates sign document request from the file, sends it to HTTPS service and parses a response. And now we need to create our send document route that will create a send document request, send it over MQ, read the response and log it into the database. So let's start from the overview what we'll need to do. First of all, we'll need to read a message from our previous route so that we have our signed document information. Now we'll need to construct a client send request and send it to Artemis MQ queue. Then we will need to parse a response and log it into the database. If you watched our previous videos from the series, you should know that some of these steps we've done already in our previous routes, so we can reuse them. For example, reading a message from our previous route should be done via direct endpoint. In fact, we already sent the resulting message of sign document route to this send document route start endpoint. So to read the initial message, we'll just need to use from route start, because that's the same route start that our sign document route uses to send the resulting message to. And now we have the first part. The next step is to construct an XML request. We've already constructed a JSON request here in our sign document route, and constructing an XML will not be much different. We'll need our model classes, our service that will construct an instance of the request model class, and then we'll use Marshall to create our request, except this time we'll be using XML instead of JSON. So let's begin from creating our model classes. We've already went through this process in one of our previous videos when we've constructed this sign document request and sign document response. So I will edit out the process of creating the classes themselves and just show you the results. Before we'll look at the classes themselves, let's go through the documentation and see what do we need to have. Our client send request should be an XML containing document ID, owner ID, base64 encoded signed document, client ID and a timestamp. And the response will contain just a status, message and again the timestamp of the response. Document ID, owner ID and the client ID we can take from the initial document's file name. And base64 encoded signed PDF we're getting from our sign document response JSON. And the timestamp we will generate. So let's return to IntelliJ. Here, as you can see, we have our client send request class that has all the required field and a timestamp field annotated with the same annotations as in our sign document response, because we'll be also using a JSON parser for it, although it will be an XML mapper this time. And here is our response class. Again, everything is the same, all the same annotations on a timestamp. Getters and setters, equals and hash code automatically generated by an IntelliJ. So nothing fancy here, just regular plain old Java objects. Now we need to create an instance of our client send request class so that our XML mapper had something to actually transform to XML string. So let's create a client send request mapper service, and same as our previous services, it will have just one public method that accepts an exchange, and this method will be called automatically without specifying it in our bin DSL element. We already done that before, so let's use getMessage method to get the values of our headers and our signed document, and that's the one way of doing it, but it's better to specify the desired class here in this getBody method parameter. Next, we can just create client send request, and in its constructor we will pass the values of our headers. First we need document ID, and we also need to specify this headers class. Then we'll need an owner ID, then signed document response base64 encoded signed PDF, and the last parameter should be client ID. And let's check that the order of the arguments is correct. So we have document ID, then owner ID, then base64 encoded document, and then client ID. And here in our constructor we have document ID, owner ID, document, and client ID. And our timestamp will be assigned a default value of local date time now. So when we have our object, we can just set it as a body of our message, because we don't need any data from this signed document response anymore. And that's it, we've constructed our request instance. Now when we've done that, let's return to our route and inject our client send request mapper service. As we're working with Spring, we can just use a constructor injection, and here in our route we can use bin DSL element and specify our client send request mapper as a bin. Again, as our service has only one method that accepts exchange, the method will be chosen automatically, and we don't need to specify it. Now, same as in our previous route, we need to marshal our request, but this time we will need to use Jackson XML marshalling type, as we'll be using Jackson XML library to do the work. Speaking of libraries, our Jackson library that we've added does not support an XML format. So we need to actually add Jackson XML starter for Camel to be able to use this Jackson XML marshalling type. Let's download the dependency, and after the dependency is downloaded, we actually need to review our setup again. As you might remember from our previous video, we have this Spring Boot Starter JSON dependency that auto-configures our Jackson object mapper. But now, as we have both our Jackson and Jackson XML dependencies, and Jackson XML mapper class is a subclass of the object mapper provided by a regular Jackson dependency, this Spring Boot Starter JSON auto-configuration encounters a problem. It has two possible candidates with type of object mapper. One is object mapper from this Jackson starter, and the other is XML mapper, which is again a child class of an object mapper from this Jackson XML dependency. So to resolve this problem, we need to add a bit more configuration. First of all, in our application.yaml, we need to exclude this HTTP message converters auto-configuration. This is the auto-configuration that is used in Spring Web projects, for example using Spring MVC, so we don't need it, but as now it will not configure a single object mapper, we need to do it ourselves. For that we will create Jackson configuration, and let's annotate it with configuration right away. And here we will have two bins. First will be a JSON mapper, and we'll use Jackson to object mapper builder to build our mapper, because this builder is auto-configured by that Spring Starter JSON dependency, and we don't need to add an extensions to it by ourselves. And for the XML mapper, we're doing the same, but passing through to this create XML mapper method. Basically, with this configuration, we retain our auto-discovery of this Jackson data type GSR310 Jackson extension, and we have both our Jackson and Jackson XML mappers configured with the extension that we need. The last thing that remains to configure is to tell Camel to use our JSON mapper and XML mapper. Again, as now we have two objects of object mapper type in our application context, we should tell Camel explicitly which one to use in its marshal and unmarshal statements. If we go to Camel Jackson and Jackson XML documentation, we will see that Jackson XML has this Spring Boot auto-configuration property Camel data format Jackson object mapper that allows us to set an ID of bin that will be used as the object mapper for Jackson data format. And same with Jackson XML, we have this Camel data format Jackson XML mapper property. So let's go to our application.yaml and add these auto configurations. Here we have our Camel data format Jackson object mapper JSON mapper and Jackson XML mapper, which we have in our configuration. And we don't need to specify name of the bin explicitly here, as it will be taken by Spring from the method name. So when we finished with Jackson library configuration, we can continue with sending our XML to the Artemis MQ. And before moving further, let's just add a log statement before marshalling, so that we knew which document we are about to send. And here as a header we'll use our client ID header, and let's close that bracket. So with our log statement ready, we can start writing our JMS endpoint. For that, of course, we will need to add new dependencies, which are first of all Camel JMS starter. This dependency contains all that we need to construct Camel JMS endpoint. And similarly to Spring Boot Starter JDBC, we will add a dependency that will auto-configure a connection factory for us with this Spring Boot Starter Artemis dependency. Let's download them. And now, when our dependencies are downloaded, we can actually create our endpoint. Remember that when designing previous routes, we've decided to make our endpoints public static final and to expose this builder object so that we can reuse the same endpoints in our tests, and if these endpoints change, we don't need to make changes both in route class and in tests. So here we will have a JMS endpoint builder. Let's call it JMS endpoint. And to create the builder itself, we'll use this JMS static method, to which we should pass our queue name. As you might have guessed, our queue name will be configured through application properties. So let's add property for that, and we will call it client send request queue and client send response queue. And same with environment variables, but instead of sign document, we will use send document. Now let's add queue request, and same with the response queue, but its value will be taken from the queue response environment variable. And when we have that, let's return to our endpoint and use the name of the property that we've just created. Now, this configuration allows us to send a request, but what about receiving a response? For that, we need to do two things. First of all, we need to add an exchange pattern to this to statement. You see, by default, Camel will just send a message to this queue and will not wait for a response. But by setting this exchange pattern in out and a reply to value here, we're telling Camel to wait for a response with corresponding correlation ID in this response queue. You can read more about it in the JMS component documentation, but basically we're enabling an automatic storage of the correlation ID and then comparing the correlation ID of messages that are read from JMS reply to and correlating messages in this way. And let's add a last parameter to our endpoint, which will be a request timeout. Let's actually create private static final value for it. Basically, it will tell our Camel endpoint for how long should it wait for a response. And let's actually change our endpoint type to JMS Endpoint Producer Builder, because that's what is returned. And now we have our JMS endpoint. It will send message to this client send request queue and will wait a response in this client send response queue. The response will be correlated to a request via JMS correlation ID header, and after 5 minutes of waiting, we will throw an exception because the response was not sent in time. And with that, we've done sending our JMS request and receiving a response. The next step is to parse a response, and if you watched our previous videos, you know that it's very easy to do. We just need to use unmarshal, then specify data format, which is XML, because if you look in our documentation, we'll see that the response is sent in XML format. And here we just need to specify our model class that we've created already, which will be client send response. And that's it. We've done with parsing our XML response to an instance of our POJO. And the last thing that remains to do is to log status into database. Well, before doing that, let's actually log that we've received a response, and let me copy the log DSL element from our previous route, and let's change it a bit. But basically, as our client send response has this getStatus method that returns the status of our response, we can just call it here in our log statement. And let's actually fix this log statement. We need to add header to access this client ID message header. And after we've logged our document status, we can actually reuse the same SQL log endpoint we've had in our previous route with minimal changes, because we're doing the same as in this sign document route. We're updating our log row ID of the entity stays the same and we still have it in the same database log ID header, and a status of our response we can still get with this body get status. So that's how we log our response status into database. And finally, let's add a log statement indicating that we've finished processing our document. And let's get a name of an initial PDF file that we still have in our Exchange file name header. And with that, our route is finished. Let's just add a route ID so that we can reference our route in tests using advice with static calls. Our route reads message produced by previously created signed document route, creates a client send request object, marshals it to XML with Jackson XML library, sends it to JMS with the help of Camel JMS, and waits for a reply in this client send response queue before a timeout specified expires. Then, if it receives the response, it parses it into our client send response object, logs the status into the database using the same SQL query as we've used the last time in our signed document route, and then just logs that the processing is finished. And as we can see from our data flow schema, after logging the final status in the database, we don't need to do anything else. This means we've finished a main data flow logic of our application. In the next videos, we will create unit and integration tests for our route that we've created in this video, as well as integration tests for the whole application. And with that, here is the end of our video on making an example of a real-world Apache Camel application. Thanks for joining. Be sure to like, subscribe, and hit that bell icon. And if you have any comments or questions, leave them down below. I will answer to all of those. See you in the next video. Until then, happy coding!